Theo chương trình thì là tham luận thứ hai với chủ đề là giảm chi phí sản xuất clinker với thiết bị làm mát thế hệ mới của KHD do ông Andreas Hanker của KHD trình bày. Ông Andreas Hanker là trưởng dự án kỹ thuật tại KHD, chuyên vào các cái quy trình nhiệt trong ngành xi măng, và ông chịu trách nhiệm về thị trường Việt Nam cũng như là thị trường các nước Trung Á. Với kinh nghiệm hơn 18 năm trong ngành xi măng, Andreas đã quản lý một số dự án ở nhiều quốc gia khác nhau, bắt đầu từ việc nâng cấp và hiện đại hóa các cái nhà máy hiện có cho đến những dự án nhà máy mới ở quy mô lớn. Andreas có bằng kỹ sư về kỹ thuật công nghệ tại Đại học Magdeburg, Đức. Vâng, xin trân trọng kính mời ông Andreas Hanker.
So also from my side, a warmly welcome to the seminar this morning. I want to give you today a presentation at first about our clinker coolers. KHD has 2 clinker coolers in this equipment which we can supply. The first one for this, I will not give you the presentation today, is the Pyrostep cooler. Pyrostep cooler is a great cooler which we have developed also in the last years with the experience which we got also from the second one, where we will get the presentation soon. We have there put in also some more developments, so it's still on the market. There's still the demand also from the clients for a great cooler system. But today I will give you the presentation of our Pyro floor cooler. It's a walking floor system. And yeah, let's just start with a presentation. So in general, I will give you just a short overview about our Pyro floor cooler. This, what is inside, when it was developed and so on, where we placed it on the market. Then I will give you a rough overview about the process features of the Pyro floor cooler. The next step will then be the description of some mechanical features of it, of the automation and the hydraulic system of this cooler, and then just a general conclusion with giving a rough overview again after this, before we coming to the Q&A session for this topic about the advantages of such cooler system. So just let's start with an overview of the Pyro floor cooler. So the Pyro floor cooler, as I said before, the Pyro floor cooler has a walking floor principle. And this was developed in the year 2005. There we had the first version of the Pyro floor cooler in our workshop presented, and commissioned was the first cooler of this type already in 2007. After we placed it on the market, you know it, when you put a new product there, there are some problems maybe sometimes. So with a reply of the clients and all these exchanges with the clients, we continue with developing this kind of cooler. And already in the year 2012, we developed the second type of this Pyro floor cooler. It's called PFC Square, so the second generation. And compared to the first one, it was suitable for the usage in the range of 1,000 to 10,000 tons per day production rate. We implemented to increase also the capacity. And the newest generation, the Pyro floor Square, which is now since 2012 on the market, is suitable even for capacities of up to 12,000 tons per day. Worldwide, we have now on the market approximately more than 50 types of these coolers. Main of these old PFC coolers were in the meantime also upgraded or changed by new developed equipment. So mainly you can see the kind of coolers which are nowadays operating are the kind of the PFC square, where I will give you now in some minutes more detailed explanations. So you see the main area where we have it on the market is the Middle East part of the world. Some also are running in India, in the Americas or in Russia. And also in the Asia-Pacific part of the world, we have 2 installations of pyrofloor coolers. So, just against this overview, so the pyrofloor cooler was just developed regarding the demands, what we were seeing on the market, and we tried to focus on standard layouts for placing it, so we have there a certain range of sizes of these coolers, where we have put it into sections to adapt the different capacities into the sizes. What are the process features of such a pyrofloor cooler compared to other coolers? The first one is the so-called pyrostatic. That's the first area where the clinker drops from the kiln outlet. This means falling down from the kiln hood. And this pyrostatic or the static grate we have equipped with a horseshoe. You can see it here in this area. It's made of some concrete and added with openings where we have also air blasters put it inside. So with such kind of air blasters, it's really easy to handle the flow of the clinker cooler on this static grate and to reduce build-ups or formations of snowmans and so on. The static grate itself is equipped with high efficient plates or grates to make a homogeneous deviation and distribution of the material, and to have also an efficient cooling of the clinker, which is falling down there, to achieve high recuperation temperatures with mostly lowest amount of air. Then another change into the pyrofloor square cooler, which we implemented now in the last years, were also an optimized cassette design for the walking floor area. With this cassette design, we try to make a uniform air distribution all over the area of the clinker cooler, to have lowest spare part costs, because with the design and with the function of these cassettes, we have nearly no wear on this area. And you can see also when you compare it with the old air pile from the old cassettes which we have used with the new one. So you see the air distribution is much more smoother, which we can achieve now with a really low pressure drop inside this area. And the last process feature, which we have also optimized in our coolers, is the distribution inside the clinker cooler chambers. So we try to arrange the size of the coolers regarding the pressure drop and the cooling efficiency, so that we are achieving a high temperature gradient by only having a small pressure drop in all these chambers. And this is giving a good improvement in the heat recuperation in the first 3 to 4 chambers, to give high secondary and tertiary air back to the process to achieve a really good and efficient cooling with low clinker cooler outlet temperatures. This means normally we achieve their temperature of 70 degrees above the ambient temperatures behind the cooler for the cold clinker, and also to reduce the installation and also the operating costs by having small pressure drops across the clinker cooler. You can see it for the first chambers, the maximum pressure which we are using there are normally up to 120 millibars only. In other plants where we saw also values of up to 160 millibars. So each millibar more air what you have to put inside is also money, what you have to invest and what you are spending through the operation. Coming now to the mechanical features of our cooler system. So the first one, what we had changed with the newest development and the changes in the Pyroflow square cooler was going from a double drive system where we had these pneumatical cylinders on the front side and on the back side. Now with the newest equipment, we have it only on the back side, just before the crushing area, where we have not that much high temperatures already. And we have another point that we can decrease the pump size for the hydraulic system. We can reduce the number of the pneumatic cylinders which have to be used. This means also the maintenance will be reduced. And the last opportunity is that we are also able to put in the first area recirculated air from the clinker cooler exhaust air, or even from bypass systems or from the preheater if there's still volume available with high temperatures, just to increase the efficiency of the clinker cooler and to increase the recuperation temperature, which is going to the kiln system itself, and to have a really optimized system to reduce also the operation costs and the heat demand of the complete plant by such recuperations. Then also for the walking floor systems, we developed the sealing system. Here in between you can see it. We have 3 different kinds of sealings in this part, and also next to each row in all 3 axes. So we have there no spillage, no material can fall down. There's nearly no wear because these cassettes are also filled with cold material before commissioning. This means you are using cold clinker or even gravel just to put it inside. The one point is to have a good air distribution inside these cassette systems. And the other point is just to have an autogeneous wear protection of the conveying system in the clinker cooler itself. Then another implementation or improvement compared to the old system is the pyrocast. This is the concrete beam directly behind the zone between the static grate and the moving lanes. In the past we used their kind of air-cooled steel structure, but there we had a lot of problems. Also there was a certain gap where accumulation of material happened. So we changed it now in the last 5 years to this concrete design. And the result is that we could increase the lifetime of this beam drastically. And we cannot see anywhere in this area. Then another option what we can put to the cooler system itself is that we have developed also new support rollers. They are so-called heavy-duty rollers. This is an option for the cooler system itself. It's not automatically inside the standard offer from our cooler, but in the discussions with the clients, we see there's a high demand to get also the new roller, support roller design with the heavy-duty rollers, because there we can have with a very, very robust construction of these materials and really increased lifetime of the rollers. There's nearly no change needed in the last years, so we have now a good experience with this. And yeah, just coming now also to the pyro crusher. There we have also made some improvements in the clinker cooler, you know it. Normally you have two kind of crushers installed there. One type is the hammer crusher, which we are still often using in our pyro step coolers, in the grate cooler systems. For the pyro floor cooler, we are mainly using this pyro crusher system. This is a system with normally 4 to 5 rollers, which are rotating against each other. And with this, we have upgraded them also with a new design with low ceilings and with an automatic central grease lubrication system. We see on this system also a very, very low wear of the rollers itself. But another point which is really important for the clients is that when you have some wear, when you see some wear on the equipment, it's easy to handle, to take each roller separately out to the side, so it's not necessary to dismantle the whole crusher system itself. You can just take out each shaft by its own, so it makes it also very, very easily in the maintenance. Coming now also to the hydraulics and automation system, what we are using in our clinker coolers. So with the newest generation, we put it also there a pretty new control system, which was designed and developed from our Center of Excellence in Cologne. It is an automatic operation system with a standby pump, where you don't need any stoppage of the clinker cooler when you have a failure in the hydraulic pump system. So all the time, normally 2 pumps are running and 1 pump is standby. We have there an automatic intelligence system also inside, which is using the pressure measurements inside the clinker cooler for optimizing the airflow and the operation of the single fans inside the chambers. And another important point is that this system is all the time maintenance and updatable from our Center of Excellence in Cologne. So in many plants we have the direct access to the control system, and it's a good feature, because we have many clients who are giving just a call, say, we have a problem with our clinker cooler, can you have a look to the system itself? And with this connection via the internet, we are really, really fast to give support when you have some troubleshootings or when you need some maintenance, some updates to the system, when there have to be some arrangements in the cooling efficiency and so on. So this operation system is already pre-programmed and tested in our workshops in Germany, where we put it together. There we have also mostly a simulation of the process, where we can see the operating of this control system. And we just can give already in the workshop an optimized set point into this system for the aeration fans. Now also some photos for the hydraulic system. As I already mentioned before, here you can see we have installed 3 pumps for the hydraulic system itself. 3 pumps installed, but only 2 pumps are running, so we can achieve with this solution a stable and continuous operation without any stoppage when there's a problem only in one hydraulic pump system. Then we have also only now 1 cylinder system on the back side of the cooler for moving the lanes. This is, as I also said before, a good improvement when you try to use recirculation from hot air from the cooler exhaust air or from other points to the plant to achieve a better heat consumption, to put in some more hot air to increase the recuperation air for the secondary and tertiary air, to use it for the system. And therefore we just changed the system with the hydraulic cylinders to give it to the back side, because there you need the cold air. You don't will have the problems with these installations, and in the front side you can put inside hot air with temperatures of more than 100 degrees up to nearly 120, 130, which are still usable for the rollers at the end. So now nearly already coming to the end of my presentation, I just want to give you a rough short overview about the advantages again of our cooler system, and I hope you have also some questions about it. Just again, overview. So very important is that we can see no wear and no fall through of spillage material on our moving lanes. We have this autogeneous protection with the gravel or with the cold clinker, which is put it inside in the before starting the commissioning or the production already. So we have there this material which is giving just the protection to the steel parts already inside. Here you can see from other suppliers some photos how they make it. So you see they have parts inside the clinker cooler in the moving area where definitely will be higher wear. So this is what we wanted to avoid with our solution. Then another topic is also the wear protection on the static grade. Here is an example from a static grade in a Turkish plant. This photo shows the grades on the static grades after 7 years of operation. And you still see these cassettes are in really good conditions. So after more than 15 years, they needed to replace the first single parts of this kind of grades. Also here now again some photos from the aeration cassettes which we have there installed. This was the photo from the new installation, and also after 7 years of operation. So only changing some in the color, but no wear was